ChatGPT and ROS for robotic software development. There are a lot of things that ChatGPT can help you in. So I will be listing down some basic features that every beginner should understand to get help from ChatGPT to build their projects rapidly. We will create package, bring a robot, pre-made URDF, and perform LiDAR scanning. And through the LiDAR scanning, we are going to be performing obstacle avoiding, getting image sensor, and writing nodes with the help of ChatGPT. That's the main purpose of this first lecture using ChatGPT for ROS development, and it is going to be a great series. So on ChatGPT, I'm going to start with create a Python package for ROS2, give commands. So here it has provided me this command. I am going to bring in my terminal, and inside of my workspace I'll go to the source folder, and let's go into the repository as well. Paste the command ROS2 catkin package create build type eminent Python, and after that I think I have to provide the package name. Yes, and it has not told me, so I'll do that. My package name is going to be AI Assistance, and it has created the package. Let's open up VS Code, and can we see the package? We have the package. In VS Code, I'm going to create a folder URDF from another repository that I already created, and then we will start working on that robot. Let's just create the folder URDF, and I'm going to go into this repository that I already have created. That is one of my course repository. I am going to bring this whole URDF file, copy this, and I'm going to bring it into a new file. Let's name it dolly.urdf. Going to paste it, and with the help of this one single plugin ROS by Microsoft, I can visualize what the robot looks like. Control-Shift-P to bring the palette, URDF, preview URDF. This is the robot that we have the URDF of. And Gazebo plugin is there, which contains the controller for command velocity, the camera plugin, the LiDAR plugin. All of these three plugins are already there in the robot. The next step we need to do is to make sure that the package knows where all the files are, and we can do that with the help of setting up things in the setup.py file. There is another way we can do that, but let's stick to that and generate a launch file from ChatGPT. If you don't know what it actually is generating, let me show you. This is the setup.py file, and in the setup.py file, all the details of the package accessibility are going to be mentioned here. So if I have created a URDF folder, the package must know where the package is. So here it says that there is a variable package.data and where you can add it, but I don't think so we have that, and that's what I will solve. I will import OS because I have to give a path from globe, import globe. That's another library that I will use. The main thing is I will regenerate the answer, but the main thing is we have to give the path in this data files. What I will do, I will just bring in the command that is going to add the path into this array, that is this big array. First entry, second entry, third entry, and custom entry of URDF file. It is not going to be like this, it's going to be a URDF file. So what it actually does, it creates a directory URDF and paste all of the URDF files inside of it in the share folder. At this specific point, we have URDF directory that is added into our package and accessible through share directory. We'll build it and we'll see. Now we need to create a launch file and a launch directory from ChatGPT. So I will say create a launch file to bring robot into Gazebo ROS2. As it is generating, I am going to go in my folder and I will create launch directory. Inside of that, let's say Gazebo bring up .launch.py. It is generating this launch file in XML, but I don't want that, so I'll stop the generation. I will say create it in Python, because I am interested in Python. And as we have created a new folder, so we have to add it into our setup.py directory. And this time it is going to be a py file. All of the py files should be inside of this directory that is going to be put in the shared folder. ChatGPT give me the code for launch file. At this specific point, you can see that ChatGPT has produced a Python launch file, but the problem is it requires some knowledge of ROS to understand that this is not enough. You can spawn the robot, but Gazebo is not running. You are not accessing Gazebo server to spawn the robot. So I'll add more commands so it can generate a proper launch file that we need. and then spawn a robot. Seems good. Let's copy it and bring it into our launch file and see if that is working or not. A lot of parameters has been provided, but we don't need that. Our package is AI assistant. The spelling should be accurate. Assistance. I made the spelling mistake, so I'll stick with that. URDF, dolly URDF. Now it is loading into a robot description parameter, and then spawn model node is utilized. Gazebo ROS is running. You have to make sure that Gazebo ROS is installed. Sudo apt get install ROS humble Gazebo ROS package is installed. Otherwise this is not going to run. I did not have it, so if I would have run it, it would not be working. So let's perform Colcan build, and everything is built, but this is a warning, depreciate setup.py. We can downgrade and solve this warning, but it does not affect in actual terms. To see the files of our package, we need to source our workspace. Source install setup bash. It should be inside of your workspace. Now it's time to bring in our robot into Gazebo. ROS2 launch AI assistance, and double tap. It is going to give me an option. We have Gazebo bring up. I'm going to press enter, and we have an error here. Let me clear this up and run this again. It says this is an error, no executable keyword argument. What I will try to do, although that's not appropriate way, I will say I got an error and I know what the problem is, but give me updated solution, because I think that error used to come this way. The launch file is written was to some extent older as far as I have the experience, but let's see if it is going to solve or not. So it says it is going to solve the problem. Let's see. It has to produce executables and add it into the final launch file. Let's see. Okay, it says that there was this problem. I think this is now depreciated. Let's see. We cannot say that it is 100% correct. We have to first make change in the code. I'm just going to copy paste and perform Colcan build. So the new changes are going to be added. Let's now run this launch file, and still I have the problem. I'm going to copy and paste this last time, and then I will bring in the real file, the problem with that file. Okay, let's see. It says that I have done this, and let's bring in the code. Although the package path is not correct, performing Colcan build and running the launch file. Again there is an error, node name. So this is one point that ChatGPT wastes your time. You can just search on simple wiki and you can find out a lot about the launch file syntax, but still it's useful. At certain points you need ROS information, you need robotics information to build a project. At this specific point I am going to bring in a new code that is again present in my repository, and I will utilize that, and then we will further use ChatGPT for the development. So let me bring in the code. The code is going to be obtained from this repository that I have. I'm going to just bring in the code, and there are certain things that you need to bring the robot in Gazebo. Number one thing is robot state publisher, and then its joint state publisher. These two things are essential, and you need them because there are certain fixed joints and there are non-fixed joints, so you need both of these. Coming to the next thing, the proper way of loading is to access through the package share directory, as taken things from turtlebot 3 launch file. This is the proper way of making an executable process of the launch file. So now I'm going to build this, although the warning is going to keep coming up, but I have to make sure that I have this package installed, a really basic package, but still I need to install it. And you can see it was not installed. Similarly, I would be needing to install this joint state publisher as well. Let's perform Colcan build, as we have made the changes and warning is still there. ROS2 launch AI assistance Gazebo, press tab and it automatically completes. Let's run it and see if it runs our robot or not. And here we can see we have our robot. And if we perform ROS2 topic list regarding the plugins, we have command velocity control plugin is working. We have scan, meaning LiDAR is working. We have camera as well. And that's a camera depth, which means a depth camera is also there. So our robot with plugins is there. So UIDF is properly configured. The next thing, I would be needing a package to drive it. This package is generic package to drive things on command velocities. It's already installed. So ROS2 run teleop twist keyboard, teleop twist keyboard. I press tab, it automatically completes. I can move the robot. Yes, I can move the robot. I'm driving it. So things are working. ChatGPT failed to produce the exact launch file we were desiring. We have to dig down to make it produce that one. But I brought another launch file as I did with the UIDF, and a robot is now in gazebo simulation. The next thing is what ChatGPT will help us a lot, and that is utilizing the sensors and producing nodes to perform certain desired actions, for example obstacle avoiding and things. So the first node we are going to write is to make the robot move in a circle. Let's see. If I stop this and go into my VS Code, I am going to create another directory, but before that I'm going to say create Python node ROS2 that is going to be publishing command velocities that drives the robot, topic to drive robot, and make it move in circles. I would be needing this directory in which an init.py function is there. I will be creating a new node, and that is going to be circle motion.py, where I will be putting all this code. It provides the explanation as well. I'm just going to copy it, and I'm going to ask it, do I just need to paste the code in py file or add it into package definition? I'll just bring the code. I think I would be needing the shebang of Python 3. As it is said that it would be good to have to read ROS2 package creation, I would further ask it adding Python node in entry point inside of setup.py. Let's see what does it produce, because I know that whenever you create a node, you are going to put it inside of these console scripts. And here you can see, after me telling it specifically to add an entry point in your setup.py file, it has produced the required thing that I had to do. So I'm going to just paste it. My circle movement package name is this, and this is not the file name. My file name is circularmotion.py. At this specific point, we are asking ChatGPT why the things we know about ROS. That's why it is telling me accurate things. But at first it was unable to tell me where to put the Python script that I created, its entry into the package. So that's a trade-off, that you have to be good at what you are working so you can utilize the structural flow of it and make the ChatGPT help you. Now, as we know, the basic structure is ready for the nodes. We can now make ChatGPT to write Python code, and it is going to be doing that job really good. So let's take a look into the code. This is our code, which is calling a class, and that class is creating a publisher and a publisher of twist velocity. Everything is imported. Amazing. Let's build it. I think there would be problem of shebang. Let's see. Simulation is running. I'm just going to perform call can build, and it has built. Let's run it. So we have my circle movement. Let's run it. So we have an error here. For just getting help from ChatGPT, I would just try to write it, solve this. I know what the error tells us about, but let's see if ChatGPT can help us with it or not. So it tells us that this is missing. Let me just try it, if that works or not. And it was also importing from this library, and we have to also bring this QoS definition as well. So I think the code is now completely ready. We have to perform call can build, and we can perform my circle movement. Let's see on gazebo. Is it circular motion? I think the velocity is really less. Let me stop it, and I am going to increase the velocity to 5 and angular z to be 8. That would be a lot. Let's perform Colcan build and then directly running the node. Speed increased, but with the increase in speed it is not taking the turn. Still it is taking very small turn. There might be problem with the robot. Let's ROS2 topic echo command velocity to see what topic it is publishing. So it is publishing the required velocities. At this specific point, our ChatGPT is helping us writing the node. It is not turning in circles because of the velocity differences. If I reduce the linear velocity, angular velocity increasing, that might cause the robot to take a turn. But the main point is, our node is directly obtained from ChatGPT, and now when we are going to utilize ChatGPT for next node, it is going to produce it without any structural error of ROS. So if we take a look into our robot where it is, now you can see as we have adjusted the velocity, the linear and angular velocity, robot is moving in circles, and if it is not visible to you, what might be happening is its joints, if they are visible, they might be rotating. Now here you can see they are rotating. This wheel is rotating, this one is also rotating in the reverse direction, so that is causing the whole robot's rotation. Coming to the point, the next thing we should be doing is playing with the LiDAR data. Let's see what we can do. Coming back to ChatGPT, write Python node. Now if I don't even say Python, it is going to still write in Python. Write a node for laser scan, 2D scan, or I should directly say write a node for obstacle avoiding by using above code and subscribing laser scan on topic scan. While it's producing, I am going to close the simulation and I'm going to bring a new simulation back. And I'm going to also produce a new file, obstacle avoidance. We also need to add it into our console scripts. These are the basic steps that we need to do even we have the ChatGPT, but this is totally going to be filled by ChatGPT. So the code is ready. I'm not going into the code. I'm directly going to put the code, take a look, and I'm going to run it. It subscribes the laser scan, and this time you see the QoS is added, and publisher is a twist velocity scan. If the laser message, there is some sort of logic, I look into it. The explanation is also provided. Twist, stop, and things are there. So let's build it, and it has built without any specific errors. ROS2 run AIAS sentence, and what are the nodes? Obstacle avoiding is there. I'm going to bring the simulation on front, and let's see what happens. The node is now running, and it is currently not sending any velocity. Let's see what ChatGPT has written. It has provided some description as well. So the code is really interesting. It has combined the circular motion and the obstacle avoidance as well. It is saying that if it checks the laser scan data for obstacle, and if it detects one, it moves the robot in circular motion. Let's try that. If it detects something like this, no, it has not detected it. If I put something here, and you can see now it has started to move, although it's not totally obstacle avoidance, but It might be rotating in circles. I can verify that by topic echoing of command velocity. What is the current velocity that is being published? It's 0.5 of x linear and 0.5 of angular, but because of some problems with the robot's design, that might be the reason. I can change it to like this, and then it would be making proper turns. Let me close the simulation and run it again. I would be also asking ChatGPT to add logging statements for CMD velocities, x and z velocity, although I'm not telling it to be linear or angular. Let's see what happens. And laser scan obstacle distance as well. Let's see if it adds the logging statement for the how much distance it is and things. Let's see what the output it does produces. Till then, we are going to perform calc and build as we have made changes in the linear velocity, and I'm going to run the simulation, run the node of obstacle avoidance, and I'm going to still echo it. So the main system was to put something in front of the robot and it is then going to start rotating. That was the behavior that ChatGPT provided. This is a behavior that is totally written by ChatGPT. It combined the circular motion and the obstacle avoiding behavior into one node. We can make changes, but the main point is it does understand what we are saying and it produces a node specific for ROS2 development. For small tasks, it can help you a lot. If you can see on the request I recently gave about logging, so if we can see logger debug, it has provided logger specified for ROS debugging packages. This get logger logging, and we can easily debug all of the values, and I was really amazed by the result that ChatGPT provides, only in this condition that you are doing it in step-by-step procedure. So for now, I think this is just an introduction what you can do with ChatGPT. Still you need some information for ROS development, and then you can get help from ChatGPT and utilize it to produce something big. And we played with LiDAR, and in the upcoming series we'll add more sensor, point clouds and things, so we can utilize ChatGPT to its maximum potential. That's it for this lecture.